Alrighty, in this video or episode here, what we're going to go ahead and take a look at is a lot of function stuff. So some of the things that we're going to go ahead and be looking at and learning, and hopefully by the end of the lesson we're going to be able to answer these questions. So how do I decide if a relation is a function? What is a function notation? How do I find domain of a function algebraically? What are difference quotients and and why are they useful? How do I build a function based on a scenario and use technology with the function to make predictions? So let's get into it. Okay, so some of the vocabulary that we're going to go ahead and take a look at is what is a function? And a function is that every input has one unique output. We're gonna be looking at that a little bit further as the lesson progresses. The domain is going to be the set of inputs for which the function is defined, and range the possible outputs for a given function. We're going to be taking a look at piecewise functions, a function that is defined by two or more equations over a specific domain, and then finally the difference quotient. When we say difference quotient, that's what it is. We're going to be unpacking that and showing you how to work it and what it all means. And so let's move on. Okay, so some of the things that we're going to have to do in this section are plug in some either numbers or functions into functions. So let's start with the first one right here, and let's evaluate f of 3 for this guy right here. So when we evaluate f of 3, that means is that all the x's are going to turn into 3's. It's also really, really important that we put everything in parentheses when we are plugging them in, okay? Simply because that's going to help us with the order operations later on down the line. So for example, I got a negative 9 plus 9 minus 3, and so at the end of the day, f of 3 is just going to be, looks like those are going to cancel out, and I'll get a 3. And when I plug in a negative 3, we're going to be doing much of the same thing here. So I have a negative sign, I go negative 3 squared plus 3, and there's a negative 3 right there. And let's knock this thing out. So that's going to give me a negative 9, a negative 9, and a negative 3. So gathering up, I got a negative 18 minus 3. That's going to give me a negative 21. Okay. So likewise is that in this first part right here, we were looking at just plugging in a numerical value. We also can plug a function into a function. So let's see how that works. Is that if I go f of x and I change the x to an x plus 1, that means is that all the other x's are going to turn into x plus 1's. So I have a minus sign, and then I have an x plus 1 right here. That x turns into x plus 1 squared plus 3 times x plus 1 minus 3. And now I just need to go ahead and clean everything up. So I have a minus, and this I want to FOIL out, okay? And we should almost be able to FOIL that out in our head by now. So we'd get x squared plus 2x plus 1. Again, if you don't remember, you can just go ahead and FOIL that out, and that's going to give you the same answer that I just put down there. Plus, and doing some distributive property, 3x plus 3 minus 3. And then we have to do this, the minus sign going into each one. And using the distributive property, I got a negative x squared minus 2x minus 1 plus 3x plus 3 minus 3. And now we just need to clean it up. And so we only have 1x squared. Let's see, we have combining this and this. That's just going to give us a positive x. And then at the end of the day, we just have all these constants to clean up. And so I got negative 4. That's just going to give me a negative 1. Okay, so that's what this guy right here is going to go ahead and be. All right, so we're going to be using those throughout the lesson. So let's go ahead and jump into the next part. Okay, so before we start to go ahead and knock things down, we're going to be doing some isolation of some variables. And so for a challenge here, I want you to take a moment and see if you can get the y all by itself of that equation. That means is that peel everything away from the y. Oftentimes students struggle with this, and so I wanted to make sure that this is all put together nicely before we start. So if you want to pause the video and maybe you try it on your own and then compare answers, now's the time to do that. Okay, so here we go. First thing I want to do is that to get y all by itself, I'm going to be moving this entire area, or I should say the entire square right there, on over to the right-hand side, okay? And you can probably hear my dog playing with his new toy in the background. So, yes, we hear you. And so the x minus 2 squared is going to go ahead and cancel out, and I'm going to bring everything down over here. So I have y plus 3 squared equals 25 minus x minus 2 squared. And it's okay to keep those together, okay? We don't have to FOIL everything out because we're just getting y by itself. And so let's see how we're going to finish off the rest of this, okay? So what I want to do is that I want to take the square root of both sides, and I got to take the square root of everything here. And this is going to give me y plus 3 equals plus or minus the square root of 25 minus x minus 2 squared. Now, note that you cannot take the square root of each one of these separate. Students love to do that, but it doesn't work out, and I'll show you why. Say if you take a look at the square root of 25. The square root of 25 we know is 5, right? However, if I were to break down, or I should say rewrite the square root of 25 as 16 plus 9, okay, which that's 16 plus 9 is 25, and then proceed to take the square root of each one of those separately. Square root of 16 is 4, square root of 9 is 3, and that does not give you 5, okay? So this shows that you cannot take the square root of each part of the radicand separately, okay? So only over multiplication or division. So from here, we're just about to finish this thing up. We have the plus or minus sign, which we know we have to do when we take the square root of each side. And so we're going to get y equals, I'm just going to subtract 3 and put the 3 back here. And so I get y equals plus or minus, and then this 25 minus x minus 2 squared minus 3. And that would be y all isolated out, okay? So, just something to keep in mind. It's a good good algebraic challenge, and it kind of like it's just a different way of manipulating the equation, so we can put everything together in a rewarding way at the end. So I will see you in the next part. Okay, in this part, we're going to go ahead and take a look at when is a relation a function. So right now we have two sets of inputs and outputs, okay? And we're going to decide if they are functions or not, okay? So the first thing that we want to do is we want to look at the definition of a function. Okay, so definition of a function says every input has one unique output. So that basically means the following. I'm plugging in one number and I'm getting one number out, okay? And that's all that means. So let's go ahead and take a look at the correspondence here. So we'd look at, I plug in a -3, I'm getting one number out. I plug in a -2, I'm getting one number out of 4. I'm plugging in a -1, and etc., etc. Now, this is where students get confused. I can plug in 1 and get out the same value that a -1 would get, and that's fine, okay? As long as I'm plugging in 1 and I'm getting just one number out, I'm okay with that, okay? And that satisfies the definition of a function still. Just like when I plug in a -2 and I get a positive 4 out, and I plug in a +2 and I get a 4 out, it doesn't matter as long as you're just getting one value out per input. It doesn't matter if the output is doubled up, okay? It just has to have a one-to-one relationship, basically. So this would be an example of a function. Now, the other part is going to go ahead and be an example of not a function. So we start off pretty good, and we plug in 0 and we get a 0 out. But look at what we do right here, okay? Is that we have these two sets of inputs for, well, basically one set of input. We plug in 1 and we get 2 different values out. So that is not unique. That means is that there are 2 outputs per one input, and that is not a function. Just like there are one input and now there are 2 outputs, and that is not a function, okay? And so when that happens, we know that the relation is not a function, okay? So what I'm going to do is that I'm going to graph or just do a real quick graph and show why the vertical line test works for kind of sniffing out these functions, if they are, or whether a relation is a function or not. So give me a minute to put the table onto the graph real quick. Okay, so that's kind of what they look like there for the data set. And what I'm going to do is that I'm going to do the orange graph first. And basically, I modeled it off of a parabola. And a vertical line test, when you have a graph, is basically going to go ahead and be able to sniff out whether or not it's a function. So with the vertical line test, you just draw a vertical line anywhere, okay, on the graph, and it will hit it just once on the graph, okay? So that basically means is that if it just hits once, it passes the vertical line test, and it's a function that we went ahead and determined before. Now, why does it work? Okay, is that it works because when I plug in one input, for example, the +2, I'm going to get just one value out. And so the vertical line tests for that, all right? When I plug in say a -1, I'm going to get just one value out, and you can see that when I go back 1 and up 1, it's just going to go ahead and hit once. That's it. Unlike the other one, the second set of inputs and outputs is that you can see that, say I go over, let's see, 4, and I do a vertical line test, I'm going to hit that graph, and it's, again, this is like a parabola on its side. Someone knocked it over. Some hoodlums. Okay, and you can see that you're going to go ahead and hit twice with the vertical line. So that is going to be not a function, which we've already determined. And so, again, it works out the same way as that, say if I go over to 1, and I have an input, or I have outputs of 1 and a -1, just like we see here, right there. It hits twice, and therefore it's not a function, okay? So there's basically 2 ways that we've learned right here to decide whether it's going to be a function. We're going to look at a bunch of other ways, but this way right here works very nicely for all your needs for this business of just deciding if you have a table, or if you have a table and deciding if it's going to be a function or not, and then just doing a quick vertical line test if you have the sketch of your relation and deciding if it's a function or not. So on to the next part. All right, so for these guys right here, we're looking for, and I don't know why the plus minus sign is, it hopped over right on top of the sign there, but we're looking for some algebraic testing for functions. And in this case, we're going to go ahead and we're going to work under the assumption that X is the input and Y is the output. And so what we're going to do is that we're going to be putting the X's and Y's, well, basically separating them out, where Y is going to be isolated in the first part. So let's go ahead and take a look at the first two, starting on the left-hand side here, is that I want to isolate Y out. So to do so, I'm going to subtract X squared from each side, and I would get Y equals a negative X squared plus 1. Okay, so in this case, when we're looking at this, if we don't have a plus or minus sign, and when we say this right there, it has to look like that. We have a minus sign, but we need both, a plus minus sign in front of the variable there, and that is going to tell us whether or not we have a function. If we don't have one, then this is going to be a function. Okay, and if I were to isolate out the Y in the next example, I would have to subtract X from both sides, and I get Y squared equals a negative X plus 1, and then I take the square root of each side, and this is where that plus or minus sign comes in, and I would get this guy right here. And this, when I have a plus or minus sign, that's when I know that this is going to be not a function. Okay, so and let me show you real quick why that is a function versus not a function. So say, for example, I plug 0 into both of those. Okay, you can see that this guy right here on the left-hand side, when this part goes away, we're just going to get Y equals 1. And so we would just have 1 point being 0, comma 1. Whereas this guy right here, when I start to clean it up, this is going to be 0, plugging it in for X. And that's going to give me plus 1, so I'd have Y equals plus or minus the square root of 1, which is just going to give me plus or minus 1. Now, that means is that when I plug 0 in, I'm getting two values. I'm getting 0, 1, and I'm getting 0, negative 1, which we know is not going to be a function because I plugged 0 in and I didn't get a unique output. I got two different outputs. And so that's why the plus or minus sign is often telltale of something that is not a function. Okay, let's take a look at the next two. Okay, so what I'd like to do for these next two right here is that let's visualize out the graph, okay? Where we know a graph, what this guy's going to go ahead and look like, and this guy is going to go ahead and look like, because when we have just a variable in input or output, such as X or Y, equals a constant, we're going to either have a vertical or horizontal line. So let's graph them out. Okay, so we got Y equals a negative 3 right here. And we can see if we went ahead and we had the vertical line test for that guy, that it would pass because it's only going to go ahead and hit once. Okay, so this is a function. However, if I have a vertical line, such as this one right here, and it is going to hit the vertical line because X equals a number, a constant, is always going to go ahead and be a vertical line when you graph it out, is going to hit the vertical line in an infinite amount of spots, and therefore that is not a function. Okay, so sometimes we just got to go ahead and visualize the graph, all right? And then the last one, sometimes we have to think a little bit outside the box. So let's see how we're going to tackle this. Okay, so for these guys, I just basically sometimes just try and draw out some a scenario in which is going to show it's going to be a function or not a function, maybe by plugging in some points. So for example, if I plug in a negative 1, for this guy, I'm going to get a positive 1 out. If I get a negative 2, I'm going to get a positive 2 out, because I'm just taking the absolute value, okay? And so it looks like no matter what, even if I plug in whatever, 15, I'm going to get 15 out. I'm just going to get one value out. However, with this guy right here, I think about, okay, if I am, we gotta think differently. Say if I plug in, let's say I say x, let's assume it's going to be 4. Now, what values of y can I take the absolute value of, okay, to give me 4? And that would be a negative 4 or a positive 4, right? Because if I plug in a negative 4, that's going to give me a 4 out. If I plug in a positive 4, that's going to give me a 4 out. So the answer would be a positive or negative 4. And likewise, I would have, okay, what 10, again, if y could be a positive or negative, right? So those are the values that are going to satisfy that particular equation. And therefore, if I look, this 1-to-1 right here works for every single one of these. And so that is going to be a function. Whereas I just have to find one case where this does not work. I have 2 answers, right? I have 2 answers, and so this is not a function. Okay, so that are some examples of how we determine algebraically whether or not it's a function. And let's go ahead and take a look at some other stuff.